positive 487 in the standard normal distribution. Now this one is in here because this is a little bit of a strange one. So probability of a z being less than a positive 4.87. This one, we're going to use that idea of symmetry again, because 4.87 is way out here on the positive side, right? And finding the area this way is what we're looking for, being less than that. And so we're going to have to find the area over here and then take the complement. So this is going to be 1 minus, and we'll just call that the z is less than a negative 4.87, since how we know that symmetry tells us that being greater than 4.87 is the same as being less than 0.487. So I'm going to go to my table, and this one is upside down and backwards. And what you see is the smallest we get here is negative 3.44. And this goes clear to negative 3.49. So there isn't anything any smaller than that. And most tables tell you that anything that's not on this, they use certain numbers for an approximation. So in the Triola book, they give you that right at the very bottom of the tables. And this one, for some reason, doesn't. I don't know where this one came from. So let me just quote from the Triola book where it is. And I thought this was my Triola table, but obviously I was wrong. So the Triola book says, gotta find that table. Triola book says at the very, very bottom, for values of z below 3.49, use 0.00001. Okay, so this one is definitely below that. So what we're going to use here is that this area is 0.0001. And so this is 1 minus 0.0001. And that would give us 0.999 and then 9 again. And so that would be the approximate probability. So you're getting pretty much 1, but not quite, because it's a really, really large number. The probability of being outside 3 standard deviations, remember, is really, really small, or the probability of being within 3 standard deviations is really, really high. We're seeing something a little bit higher. So that hopefully would make sense to you. All right, now you should try these 3 probabilities on your own. The probability of being less than a negative 1.3 in a standard normal, being less than 1.52 in a standard normal, and being less than a negative 3.51 in a standard normal. So I would highly recommend that you just go ahead and shut off your video and try those 3 problems, including making the notations. And I'm going to go ahead and I'm going to do the same thing, and then when you come back, they'll be here. Okay, so here are 3 probabilities with notation and with little pictures. So this one is a straight up table lookup, so I'm just going to go to my table and I'm going to look up negative 1.30. So here's negative 1.3, here's 0, so my probability, straight table lookup, 0.0968. And that's my probability. So the area under the curve over here, 0.0968. All right, now the next one, the probability of being less than a positive number, well, I can't look this up in a z-table, but I can look this area up by using the idea of symmetry, that this is equivalent to the probability of a z that's less than a negative 1.52. So I can look that up in my table, negative 1.501 and then 2, so this one right here. So that looks like 0.0643, but that's not what I need to solve this problem, because this one is the complement of what's over here in this. So this is 1 minus that probability that a z is less than a negative 1.52. And so I'm going to be subtracting 1 minus 0.0643. And so that's going to look like 0.9357. And that will be my probability there. And again, look at this. It looks it looks like it's almost the whole curve, right? So there's a little bit less than if it were one standard deviation over here in the tail. So remember, if it were one standard deviation, there'd be what, 68 minus 100 minus 68. So there would be 32%, which half of that is 16 in each tail, and it's a little less than 16%. And this we see, yeah, it's in the range, right? And that's all you can do is kind of give a ballpark, because these curves don't go down in any particular way. They're slightly sloping off, so we don't know how fast that is. Now here we have a probability of a z being less than a negative 3.51. Well, that's beyond our table. So in the Triola book, they would tell you to use approximately 0.0001 for any probability that is less than negative 3.49. All right, so that is our standard normal probabilities. Now this next section is finding these with a calculator. And I did do this with a calculator, and there's a little video in my selection of videos and in my playlist where I go and I use the calculator. So the next thing that we're going to do is finding probabilities of being more than or being between two values. So let's just take a look at these examples right here. So moving on to another page here. We have the probability that I have more than a negative number, so greater than a negative 1.52. So I draw up the picture first of all. Here's my picture, here's my 0, here's my negative 1.52, and I'm going to shade that in over here. That's what I want for my probability. Well, I can't find that in a z-table. I can only find this over here. So that's the complement of what I can find. So this is going to be 1 minus the probability of a z that's less than negative 1.52. So I can go and look up the negative 1.52 in my table. So let's go to the table. So my table is negative 1.52, so there's my negative 1.52, so this is 1 minus 0.0643, and now subtracting it from 1, 0.9357, just like we had in the last problems. Okay, now moving on to the next one. My next one says the probability of being more than 2.3. So z is more than 2.3. So now I have my picture, and here's my 0, and then 2.3 over here, and I can't find a positive in a negative z table, but I know because symmetry, right, it would be the same as this area that's less than a negative 2.3. So I know that this is equivalent to the probability of being less than a z less than negative 2.3. So this, I will just go to my z table, and I will look it up as negative 2.3. So that probability right there, 0.107, is the probability of being greater than a positive 2.3. So there's my probability. My next one, I want the probability of being between two values. Now these can be a little bit tricky. So small number is 2, less than my z is less than my bigger number 3.1. So this really helps us if we draw this out on the number line. So I have my 0 here in the middle, and here's my 2, and here's my 3.1. So this area in here is what I need. So because we're going to use a negative z-table, let's just go ahead and put in the symmetric one so you can kind of see what I'm thinking as far as symmetry. So here's negative 2 over here, right, because negative 2 is closer to here, so the symmetry would be closer here. And then negative 3.1 over here, right, there's your symmetry. And so there. So if I want to find this area, what I can do is I can start by saying, okay, if I find the area here, and then I take out this area, if I take out this area right here, then I'll have what's left solid, right? So this ends up being the probability of being less than a negative 2, and subtracting from that being less than the negative 3.1. And that's how I can find the probability of being between two things on my tables. So if I go over here and I say, okay, so negative 2, so here's my negative 2, that's 0.0228, so 0.0228, that's all this area that I had highlighted before, right? And then I find the probability of being less than negative 3.1, that's that value, 0.0010, and that's what I'm subtracting out here when I erased to leave me what's in between them. So it's 8 minus 0 is 8, 2 minus 1 is 1, 2 minus 0 is 2, and 0 minus 0 is 0. So we have 0.0218. All right, now moving on to my next probability. My next probability is between a negative and a positive. So this one is a little bit more of a dilemma. When I have between a negative and a positive value, this